Welcome to Lesson 51, Modeling with Systems. Here's our criteria for today's lesson. Number one, we're going to consistently read and annotate our word problems and use the system of solve to solve the problem. Then we're going to choose and define two variables to represent the unknowns using what's called a let statement. We're going to write two equations to represent the situation, and then we're going to answer any follow-up questions by solving the system of equations. Here's our first problem. Dylan has a bank that stores coins as they are dropped into it. A panel on the front displays the total number of coins inside as well as the total value of these coins. The panel shows 90 coins with a value of $17.55 inside of the bank. If Dylan only collects dimes and quarters, write a system of equations in two variables, or an equation in one variable that can be used to model this equation. So what are they basically asking? Let's state it in our own words. That would be our S. They want us to write a system of equations using these variables. All right, so let's create the variables and organize these facts. We know there are dimes and quarters, so let's let X equal the number of dimes. Let Y equal the number of quarters. And so for our system of equations, since we know that there are 90 coins and they make up dimes and quarters, so dimes plus quarters, the number of both, we don't know them yet, equals 90. So we know we have 90 coins. And the second part has to do with the value. So we know that each dime is worth 10 cents. So I'm going to write that as 0.10 times however many dimes plus 0.25 times however many quarters is equal to $17.55. And that's my system of equations. Let's look at the next question. Use your equation or system of equations algebraically determine the number of quarters. So we want to know number of quarters Dylan has in the bank, and we want to use this algebraically. So we can't use graphing for this one. All right, so I'm going to hit pause for a second. Let's set up our calculator. I'm going to use elimination method for this. So I know D plus Q is equal to 90, and 0.10D plus 0.25Q is equal to 17.55. Now, when they say algebraically, I have two options. I can either use elimination or I can use the substitution method. Doesn't matter which one. I'm just going to choose elimination for now because I think that would be the easiest. And I'm going to decide to eliminate the dimes by multiplying this entire equation by negative 0.10. That's going to be my goal. So the first two numbers are going to be easy. So negative 0.10 D and negative 0.10 Q. And now I just have to do the same thing with 90. 90 times 0.10 would be 9. So that's going to turn this into negative $9. Okay, let me rewrite all of that to make sure it looks really clear. So negative 0.10D plus, actually let's put it as minus 0.10Q is equal to minus $9 plus 0.10D, 0.25Q, $17.55. This eliminates, nice and easy. 25 cents minus 10 cents gives me 15 cents. 0.15Q. And here I'm left with 8.55. Let's verify since I have a calculator. There we go, 8.55. All right, so let's solve for Q. I'm gonna just move this over. 0.15Q is equal to 8.55. Divide both by 0.15. And Q is equal to, oh, this is missing a decimal, there we go, 57. So there are 57 quarters. And that was all I need to figure out how many quarters there were. So let's hit pause and jot this down into our notes. All right, let's do the next section. So Dylan's mom told him she would replace each of his dimes with a quarter. If she uses all his coins, determine if Dylan will have enough money to buy a game priced at $20.98 if he must also pay an 8% sales tax. Ooh, okay, so what do we already know? We know that he had 90 coins. 57 are quarters. So what if all 90 were quarters? So rather than just subtracting, what if all 90 were quarters? So I'm just going to multiply 90 times 25 cents. And he has $22.50. Now, we do want to know if he has enough money to pay for the game with 8% sales tax. So here's the game. The game is $20.98. And to figure out the tax, I'm going to multiply it by 1.08. All right, this will tell me, the reason I'm doing the 1 is because that will tell me the whole price, the whole 100%, plus the 8%. 20.98 times 1.08 is $22, and I'm going to round this to the nearest penny, 66 cents. So he does not have enough money. He only has $22.50. So I'm going to put that into my justification. Dylan would not have enough money for the game with sales tax. Even with his mom's contribution, he only has $22.50 and is 16 cents short for the game. So close, Dylan. So close. All right, hit pause and jot this down into your notes. All right, we're going to get into the next problem. But again, if you wanted to figure out how to do a percent increase, you can just add it on to here. So 1 would be 100%, and I'd either add on or subtract from that 1 to do a percent increase or percent decrease. Let's go on to the next problem. Let's jump into our guided practice, and here we go. Two friends went to a restaurant and ordered 1 plain pizza and 2 sodas. Their bill totaled $15.95. Later that day, 5 friends went to the same restaurant. They ordered 3 plain pizzas and each person had 1 soda. Their bill totaled $45.90. Write and solve a system of equations to determine the price of 1 plain pizza. Only an algebraic solution can receive full credit, so no graphing on this one. All right, hit pause and solve this using your system of equations. Either substitution or elimination. Okay, and we're going to show the solution. What is the cost of 1 pizza? And here we go. A soda is $1.95 and a pizza is $12.05. So if you got a different answer and you're unsure why, or you want to see the walkthrough, follow the link in the description of this video and you'll get a bonus video that will show me going through this entire problem. That's it for today's lesson, Math Marbles. I'll see you in the next one. Be well.